Hello, I'm Mike Ryan.
And I'm Ian Falconbridge.
Welcome to Introduction to Systems Engineering. We hope that you'll enjoy the course over the next 9 weeks. The topic we're going to cover is called Systems Engineering. That is, the engineering of a system. We're therefore going to cover a very broad range of issues because systems engineering is an approach that involves many professions in a combined effort of design, implementation and evaluation, and that's what holds the key to the successful development of a complex human-made system.
In this course, we'll provide you with a framework encapsulating the entire systems engineering discipline, clearly showing where the multitude of associated activities fit within the overall effort and how those activities relate to one another. Since systems engineering is such a broad discipline, we also discuss how the concepts and procedures can be applied to individual projects. And to help you visualise the application of systems engineering, we use a number of examples throughout the course, including an example of a domestic dwelling. These examples will be used in both the presentations and in the exercises.
The course will run over 9 weeks, covering 8 major modules and a 9th summary module that concludes the course. Each module will comprise a number of online presentations and then some quizzes and some exercises to give you feedback. For those of you that want a deeper level of engagement with the course, we have 2 tests and a number of extension exercises for you to complete. So let's look now at the content for each module in a little bit more detail. So the course begins with this introductory module, in which we address the nature of systems and the concept of a system life cycle. We identify what is meant when we say that something is a system, and we narrow down the very broad definitions of such a thing to focus on human-made or human-modified systems, and those are our interests in systems engineering. We then look at the very broad phases and activities that a system moves through during its life, through what we call the system life cycle. From the early identification by the business of the need for the system, exploration of options, the functional design of the system, its physical design, detailed design and development, construction and production, and then deployment of the system into service, its utilisation throughout its life, its support, and then finally retirement at the end of its life. Systems engineering supports all aspects of the system life cycle. So in this second module, we describe the discipline of systems engineering and outline its relevance and its benefits. We introduce what we mean by the term systems engineering, and we provide a framework within which we can consider the major processes, the activities and the artefacts throughout the remainder of the course. Now in doing so, it will have become evident to you that systems engineering approach has a number of advantages. So we'll also examine in this module the relevance and the benefits of systems engineering. Before we begin to look at the various systems engineering activities in more detail in forthcoming modules, in this module we look at what we mean when we refer to the needs and to the requirements for a system. We examine what we call the needs and requirements views that are developed by business management, business operations and systems designers. We'll also consider how we might go about developing a set of requirements. We call that process requirements engineering. In Module 4, we explore requirements engineering. That is how requirements are gathered and then defined formally through a process we call elaboration. And it's through that process that we develop a formal set of requirements. We also look in this module at some simple requirements engineering tools, and we illustrate how they might be useful to you. Finally, we examine the notion of traceability, which ensures that we know where each requirement comes from, which requirements are related to it, and which requirements come from it.
Next, we examine conceptual design, where we investigate how business needs and requirements and stakeholder needs and requirements are translated into a system-level understanding of the requirements of our system. This understanding will tell us what the system needs to be able to do, how well it needs to perform, and what other systems it needs to interact with in order to meet the stakeholder and business needs and requirements. We then have a look at the concept of system-level synthesis, where we make some high-level design decisions before reviewing our work in preparation for the core design effort normally associated with preliminary and detailed design. In Module 6, we pick up from where we left off at the end of conceptual design, and we discuss how we start making some more detailed design decisions. During preliminary design, we will look at identifying the various subsystems that need to come together to form our system. What do those subsystems need to be able to do? How do those subsystems need to interrelate? Can we source those subsystems off the shelf, or do they need to be designed from the ground up? These are key questions of preliminary design. For the subsystems that need to be designed or modified, some level of detailed design will be required. We will look at the detailed design process and talk about the tools like prototyping and how those tools help to refine the detailed design. We then move on to constructing and producing the system against the detailed design from the previous stage. During construction and production, we look at critical systems engineering activities such as configuration audits and system verification. The system then enters the utilisation phase, where we explore how systems engineering may continue to be involved via modification and upgrade projects. We finish this section by looking briefly at some of the issues we face when trying to dispose of or retire systems that are no longer required. In this module, we explore some of the key management issues that systems engineering must address in order to maintain balance and control across the systems engineering effort. We look specifically at issues such as verification and validation, configuration management, technical risk management, and the management of the technical review and audit program. We also explore some of the broad strategies that might be adopted when executing a systems engineering process. Whilst we have used what is generally referred to as a waterfall approach throughout this course to explain systems engineering, in this module we also briefly introduce alternatives such as the incremental and evolutionary development approaches. We conclude the module by emphasising the importance of planning and tailoring throughout the systems engineering program and the development of a governing plan known as the Systems Engineering Management Plan, or simply the SEMP.
Module 9 concludes the major material for the course. This final module provides a brief summary of the course, but also provides feedback for you on the assignments from Module 8.
As well as the presentations, the course is also supported by a number of other course elements. At the end of each module, you'll be able to use a number of online quizzes to provide you with feedback as to how well you've absorbed the material. You can attempt these quizzes as many times as you like, and there's no time limit to complete the quiz. At the end of each module, there are also exercises that will provide you with feedback on the application of the module's content. Each exercise will have suggested solutions posted so that you can confirm how well you did.
For those of you that feel you wish to engage more deeply with the material, there are some additional tests and extension exercises. When you feel ready, you can complete the appropriate test, but please remember, unlike the quizzes, you only have one attempt at each test within the time limit. Also at the end of each module, there are extension exercises that you'll hand in and have assessed. Feedback for those extension exercises will also be available once they've been assessed. Please also check the additional resources we provide for you. There's a glossary containing a list of abbreviations and acronyms, which you'll definitely find useful if you're meeting the material for the first time, a list of associated readings, and some links to related materials that you may be interested in. Although the lectures are designed to be self-contained, we recommend, but do not require, that students refer to our textbook, Systems Engineering Practice. It's available from Amazon or from the publisher. Now, the text is not required, but it is useful if you wish to support the videos with textual information. It's a little easier to read. The relevant sections of the text are listed in the reading, course notes and textbooks. For an abbreviated description of the material, we also recommend, but again don't require, that you refer to our electronic book, Introduction to Systems Engineering, which is also available through Amazon. We've also provided a list of suggested standards, websites and books that may be of interest to you. Please see the reading Other Useful Resources. You may also be interested to hear of the Master of Systems Engineering program at UNSW Canberra. The program is purposely designed to provide modern postgraduate students with a program that broadens their knowledge and skills rather than deepen, as they might in a traditional science or engineering program. Consequently, enrolment in the program is open to students from any disciplinary background. The Master of Systems Engineering program comprises 8 courses, which can be completed over 1 year full-time study or an equivalent part-time period. There are 4 compulsory courses: Systems Engineering Practice, Requirements Engineering, Test and Evaluation, and Systems Thinking and Modelling. And then there are 4 elective courses. By choosing 2 of those 4 courses from a nominated set, students can specialise in networking, maritime systems, space systems, test and evaluation, electronic warfare, weapons and ordnance, simulation, or reliability engineering. Now, all of our courses are offered asynchronously, that is, you do not have to be logged on at any particular time. All course material is available to you at any time. So if you're interested in our Master of System Engineering program, more information is available in the video in week 9.